So today in this video, Dr. Dilip want to make some principal scientific stage by us in So now I am
বক্সটা ইকো হচ্ছে বক্সটা
Now I would like to share the introduction. Dr. Dilip gradually aiming from 1994. He pursued a master's degree in mechanical engineering in 2003 from Durgapur. Then he came to the most academic phenomenon of multi-agent system of mobile robotics. He has started his PhD in 2022 from Jadavpur University, focusing his research on driving real-time mobile robotics. Throughout his academic and R&D journey, Dr. Dilip is dedicated to scientific excellence and commitment of addressing the critical need for advanced design and development of various mobile robots. Autonomous system as well as the machine automation are as per the need of modern scientific world. So thank you. Now that I you.
আমার মনে হয় বাংলাতেই মনে হয় ভালো খালি am I audible? Yes, yes. হ্যাঁ বক্সটা ইকো হচ্ছে আসতে পারে তাহলে শুনতে সুবিধা হবে আপনার একটু এগিয়ে আসতে
And good afternoon to all of you. So let us start to learn something about the modern trends in technology related to robotics and its allied fields. So
like to talk
the topic
like
is huge. Because robot is a ocean, and I know one drop out of that. So from that first question, we are trying to discuss only about the robots and its related industry, its application as well as that is industrial application as well as scientific exploration. So beforehand, while we are listening the word robot, we are thinking it's a machine just like a man or human being. So what human being is doing, that machine will do that. So that is our imagination. To bring that imagination in practice, we need to travel a long road like this. This one was first the word robot came from some artistic point of view. So that was a servant, and servant means we are thinking it is a human being. So that we just think that one, imagine that one is we will develop one that type of robot which will act and work as a human being. So how to start from? So what is its chronology? That is history. So the engineers and the scientists, even students, and whatever may be the contributors, innovators, they start from the very beginning. So how they work. So from legs to this is the latest one. So one after another that is developed. human is evolving and these machines are developed. So starting from beginning, it is developed. So developmental stages are defined. So we are in certain phase so that this robot can be utilized in industry as well as scientific exploration. Now in this stage, but that is also few robots are used in industry, but not all. And those robots are fixed special, not mobile robots. Very few mobile robots that those are used in industry for only to carry some material. And coming one by one. So only fixed base robots those are used in industry. So in this discussion, we will follow this robotics, types of robots, anatomy of each and every robot. Those are different. So those things, and the relationship between robotics and automation, and then use of these robots in industry and for scientific exploration. And I will touch where I am. That is our team. My team is actually patient. I will take some more time because it has 200. There are about 200 slides. I will go fast. Okay. So first is robot and robotics. So we will develop this mechanism, simple mechanical arm. So how this mechanism can be converted into robots? That is, another one is mobile. This thing, there is no electronics, nothing, only mechanical. Both of them are mechanical parts. So this mechanisms are working. So one is fixed base, another is mobile. Both are man-made mechanical devices. Now, how these things will be a robot? So to make this mechanical equipment that is converted into a robot, these things are very essential. That is what we are doing. First of all, this machine is operated by some operator. It has complete sense. We have to act. But what acting? He is just moving some levers so that the machine can act according to his instruction. That's why that is planning. And action is the machine action, not our action. So if these things are there in a machine, then only this can be converted into a robot. So a robot is a machine specially programmed, because nowadays program has developed. So we are autonomous, but machines are not autonomous. Till just that is trying to be completely autonomous, because of there are various constraints in any of the robotic system, which one is fixed or mobile. There are various constraints. We are not going to the technical details, but I am going to just specify some of the robots what are there, what they are doing. So basically, robot nowadays is fully dependent on robot programming, that is computer. So computer has developed. So as computer programming is developing, it is super fast. Then you go to action, robotic action will be super fast. So robotics that deals with the technologies related to whatever technology, whatever science, whatever the applications, which senses, action, everything is related to everything in the robot that is related to. So that is the field. Robotics is a field, that is the study field where students and researchers, innovators, they will have to consider. So this importance is known as this computer programming has developed. So this increasingly prevalent in the students. This robotic because it is increasingly prevalent in for students' lives in what their future. So they should have to be very much compatible with programming. But you know that except your computer science, we are not much capable of writing a program. But if there is one robot, we are giving some instruction according to, and then if it is practically, if we see, then we can easily develop the program. That is programming skill. But programming is very much complex. So as we know, now nothing is single disciplinary skill. Nothing. Everywhere there are all the streams are involved. From mechanical to civil, computer science, electronics, electrical, everything is involved. There also, as a robotics is a multidisciplinary thing, and basically it's related to basic science, not completely your applied science. It is in between basic science and applied science. So basic things are there. Still, so many things are there that is not developed. Even by your programming, nothing is developed. You can see somewhere we are struggling how to solve the problem. So, as we are following certain law that we should not deal with this object. So, in robotics, we have to follow such type of rules. There are 4 laws. Beforehand it was 3 laws. Another one is added later on. So there are 4 laws. So robots should not do any harm to humanity or human. It should not create any harm for himself also, for itself. And it should follow the instructions whatever given by human being. That is whatever in the program, whatever it is written in the program, that instruction it will have to follow. That is those are the laws of robot. So robot has many advantages where we cannot go, where the accessibility is very less. Suppose you are underwater or in space, or even in atomic reactor, or that kind of complex environment, complicated environment, hazardous for human beings. There robots are very useful. That's why it is very important. But disadvantage is that it needs continuous supply of power, where humans just take something you can work for 8 hours, but it cannot. That related to your power system. If it is autonomous, then it is very much restricted. So before completion, before your exhaust of power, the system will have to come to the station. Then its maintenance. That is another problem. Though human also require maintenance, if there is any disease, we need to take some medicines. But here regular maintenance is required. We can control ourselves, but we cannot. Then cost. Cost is another problem. As it is intelligent, it is becoming more and more intelligent, cost will increase. And also there is something that people will lose their job from the time. So this is one thing how this human being, they are copying, replicating in the world. This action of the human being that is replicated in the. So what is that? So for each and every human being as well as the animal, they have some few building blocks, essential building blocks, and similar things will have to be there for an intelligent robot. like body, locomotor, how it is moving. If it is mobile, if it is not mobile, then this thing will not be there. Then energy, sense, and its brain, that is control. So both of these things we have to think. Then only this robot will be complete. So that's why a robot is an autonomous system. It should exist in physical world, because it should, on the imagination will not work. It should exist in physical world. It has the ability to sense the environment, and from that sense information, it has the ability to extract the what is there around it and what it will have to do. Then it should have some predefined knowledge base. This is the program. It will be reprogrammable. Robot is reprogrammable. This is the knowledge base. It is collecting knowledge and is saving the document as well as we are just keeping books in the racks. So this is we are just storing data in computer. That is not this. So that is the knowledge base. Then what it will have to do is the most important one. It will act safely following the laws of robotics, and that action should be meaningful. Otherwise, it will not be utilized. Because that is our purpose. If we want to make one servant robot, that purpose has to be. So out of this, if there is a robot which can move, mobile robot has some locomotor by which it can move from one place to another to perform some task. Fixed robot is doing the work at that point within its working zone. That workspace is fixed for fixed robot. Workspace is very much limited. So its reachability, whatever its reachability, that is its possible. But for mobile robot, reachability means it's on the inline manner. So that mobile robot will become mobile due to this locomotor. So that locomotion is very much important, because this thing, this locomotor will be selected by considering its terrain, mechanical complexity, and how to control the action of that locomotor. That is control complexity. Then how it will manipulate. That is just like a manipulator. How it will, if there is an obstacle, how it will avoid that obstacle, or how it will grip that somewhere to move some movement. That is climbing. Then it should be stable. We are stable because we have inverted pendulum system. That is in our gear. And if there is not, this stability is not there, then there is no use of that. So if we fall, we cannot fall. Then its efficiency, maintenance, and its navigational aspect. All the things will be considered for locomotion. And these locomotives are wheel, leg, arms. Wheels only give rolling motion. Leg will give this type of motion. Walking, crawling, climbing, jumping, hopping, etc. And arm can swing, crawl, even climb also. So this is some of the example of wheel locomotion. Some more examples. All are wheel-based. So these are the wheels that is available also in net also, you can get it. And wheels, which is very popular, that is wheels is discovered long back, while they were just people were trying to take some heavy weight from one place to another, then that rocks were just rolled. That's it. That was the starting of just the discovery of wheels. But legs, when legs started, that is in modern age. Leg movement, the mechanization of leg is started in modern age. While robot arm was developed, the arm was inverted, and then that arm is acting as a leg. So you know it is an inverted mechanism, mechanical inversion. So that arm will invert, arm is fixed at the base. If you invert, arm will become a leg. That's why wheel is the popular one, because it can roll on surface. That is mostly flat surface it is better. This action is this. But disadvantage is that it cannot go in rough terrain. For rough terrain and your hilly areas and marshy areas, if there is your gravels, then it will give trouble. Tracks are mostly mostly that is a track. This one is track. This one is track. And this is speed steering. Tracks are you have seen mostly in the fighter tank. Fighter tank there is tracks. So the tracks also is used for as a mobile locomotive. These are the tracks. So its advantage is that it can go in rough terrain, marshy terrain, even if there is gravels or some stones that is spread around, it can go. But main disadvantage of the track is the traveling. So after that we are going for walking robot, that is the legged robot. Walking robot is also a man-made mechanical device. It can move by themselves. Motion, everything are imagined and then their imagination is modeled, planned into this walking robot. The area also influenced by programming. The area means how it will fight the obstacles or how it will move from one place to another. That's the area. That walking robot or the legged robot may be intelligent. If we put that intelligence in it, then only it will be intelligent. It may be autonomous if there is power source. Then it will be autonomous. And if you program that one as well, then it will be autonomous. So for walking robot we need leg. Leg is also leg depends. Actually leg is very much useful for the rough terrain, marshy terrain, even in your hilly areas. Mostly the single-legged robot is not there. Only the stability is very much important in legged robot. The single leg cannot give the stability while it is static condition. Only in dynamic condition it can give some stability, but it will not be static. Always it will be dynamic in motion. Two legs, the hybrid robot already developed, but thing is that two legs also while it is lifting one, it is becoming one support. But that supporting area is huge, much more comparing to that monopoly. Then quadruple, four-legged robot, and then six-legged robot, and maybe you can go for lakhs of the two legs. There is no problem. But these robots were developed at this stage. Still, more than 8 legs are not. They are not present. More than 8 leg robot is not present. That is not commercialized. Coming to that one, creatures, we can model the leg, and accordingly that can be controlled. And we can use that leg in a and the disadvantage is that mechanical complexity. Its electronic complexity control very easily. That is the disadvantage. So these are some of the legs. This is monopod. MIT has developed this one, this copper, and monopod, then bipod. This is from German, and this is tripod, Arunodi. This is from Japan. Now we can go for quadrupod, then hexapod, 8 legs, and this is for underwater application. So similarly, arms and levers, those are also there for your locomotion. Arms, our arms are being, as we are just using our arms to move from one branch to another branch, or while we are just moving in the road. That type of arms are also developed for robotic application. So it's very simple, but design is very much complex. You can think that arm is very much simple, but design is very much complex. And also your control is very much difficult. Here one advantage is that you need not use any inverted pendulum. That is, your stability equation is not much complicated while you are doing for arm, but support is required. While it is moving, that support, arm supports speed. So these are some of the arms. This is Dilip, just like Hydra is here. One small animal, water animal, Hydra. It is moving, clipping this one. This is crawling, and this is also crawling the wall animal. So these robots are also already developed. Now air rest may be remote control or may be unmanned, or may be remote control or may be autonomous. Autonomous sometimes vehicle, where vehicle is very much limited, but remote control vehicle are there. Even Siemens also developed the remote control air rest. So advantage is that you can escape somewhere from the air, so there is no problem in traffic jam or other things. And your this problem in the your terrain problem you can overcome by using this type of. Disadvantage is that if this crash, then the whole investment will go. That is the thing. Not only this airgun, in underwater, if something happens, you lose. In space, if something happens, that system will lose. But only if something happens on your land base, that vehicle we can get. Some portion we can get. Cannot get 100%, but we can get some. So this is one very simple flying robot. These are the parts of the flying robot. Now, already I have just underwater water-based. So water-based motion, that also given by underwater robot, that is some structure, things or like that. So these are the underwater or water-based robot. That is already present in some institutes and organizations. All are autonomous. Some are feature-based also. Now you can see there are some hybrid robot also. So hybrid actuation also there, hybrid locomotion also there. So advantage is that system is hybrid, not only walking, not only our system. Human beings are hybrid, even in most of the animals they are hybrid. Because of they have action for moving as well as they have your manipulators. Even our tree is also one animal. So we are hybrid system. So there are some other locomotion. You can see this serpentine. This is mechanical, but this motion is wheel, but action is legged. This is wheel motion, but action is as well as legged. This is what is also some other locomotion. So this is the very important thing, how the robot become intelligent. Only depends on the sensor. We are intelligent. Our sensors are very strong. That's why humans are the proper. So if your sensor is much more complicated, then you are much more intelligent. If your sensor system is simple, level of intelligence is very small. Just like you see. So let me see this. Sensors are either contacting or non-contacting. That is touch or non-touch. So contacting sensors are force sensor and touch sensor, just like our skin. And non-contacting is proximity, machine vision, that is camera. Then various other type and optical sensors. Here I have. So what is a sensor? Sensor just which is sensing by that device. If we are sensing the environment as well as the zone where we have to act. So sensor collects information, and that information is mapping with the environment as well in the outside environment as well as internal environment, whatever data stored inside. So if you have one object, square object, you know this should be a square, whether it is matching with the square or not, that is environmental sensor, that is internal sensor. So if it is matching with our internal things, then we can say this one is a square. So sensors either mapping with the environmental attributes. Then this sensor is based on transaction sensor principle. So sensor actually what it is doing, it is converting the energy into from one form to another. So there are something. This is one very small example. So if we do not have any sensor, how will it behave? So just you can practice this. Close your eyes, plug your ears, hold your nose, tie your hands behind your back. Then you shut your mouth, tie your shoulders together, shoelaces together, spin yourself around in your feet. Now what? How does it feel? That is without sensor. You feel things even now without sensor. These things you do, new things you will do, you will see that there is you have no sense in what you will do. That is a machine. How a machine will be, that same human being will be become one machine without sensor. So sensor is very much essential for the system to be intelligent. So these are the some sensors which are just imitated from human point of view or from animal point of view. So some things are not accessible, some things are accessible. Human perspective is one, but the sensor philosophy or sensor theory is another. The sensor is always converting energy. We are also converting energy. Whatever I am taking, that is inherently it is stored already inside our brain or somewhere in brain cell. So that is also stored. But the storage, if we go inside, how that is storing? That is from electrical energy. And if you go for electrical physics, that is called E and N. So either on or off, energy is stored there or not. So that is the exactly it is coming to chemical. So we are also storing the data and whatever information we are storing in the chemical. So our brain is storing everything like that chemistry. So the sensors are imitated from the action of or and senses of human being as well as from animal. So some sensors are very simple, some sensors are very complex. So complex sense will give you more, that is provide you more intelligence, and simple sense will give less intelligence. Now you can see sensors provide raw information. That information is raw because it is either switch on or switch off. It is either your power is there or not, or wave is there or not. So that raw information it will give, and then you will have to process. That's why that process has various ways. As we are processing, our brain is huge comparing to all other parts. Number of cells in our brain is much more than the number of cells present except brain nerve cells. Except nerve cells, how many cells are there within our body? That is very less. Except nerve cells is trillions of nerve cells. And how they are connected? They are connected by synapses. That's two connections. If there is any mismatch, then it will be gap. So that also I am coming. If there is any gap, then we cannot recover. That's why somebody has something like lag sense. Is telling that he have less sense or his IQ is very low. Low means it is not, that is lacking. That synapse is not formed. But number of nerve cells of a mad person, even in a normal person, number of that ends, tentacles, that is also same. But while they are just interacting, that connection is not. That's why people are telling it's a loose connection. So raw information is processed for various purposes in various ways, and then it is utilized for our robotic application or any application. So how to detect? Temperature detection is by this sensor, movement by motion sensor, shape by camera, compression event, some enclosure, some force sensor also. Then color, this is image processor. Color is image processor. So some other things also, ultrasound, infrared, illumination by two camera, laser lens finder, then light structure, light array, grid, all are the detection method. Then biology, because everything is copied from biological sense. If it is not present, then you cannot, or innovators cannot do that. But somehow something we are just missing. We can see from the glass, then we can reach towards the glass. But if there is light, camera cannot see the glass. That's why some other options are there. That is called what is redundant sensor. So the multiple sensors are used for one processing. So all the data, all the sensors processing. So that is very not much complicated, but it's very difficult. So we understood that sensor. The human sensors convert information about the environment into neural code. So neural code, that is what I can say is what I understood. That is neural code means here it is only the chemical combination. Only that your either negative or positive charge. So in our brain can understand. So touch, that is in the touch sensor is embedded in skin. Visual, that is retina. Ear, that is in our ear. So accordingly, that your that sensor, your touch sensor, that is contact sensor is developed. Visual, that is camera is developed, and ear, that is sound, ultrasound, sonar, that is also developed. So our brain needs to understand the neural code before we can react. Since we will be programming the robot, we will need to understand the output of the sensor before we can program our robot to react to different stimuli. Because if we, after collection of the sensor data, if that is not processed properly, then the robot cannot react what to do in the next step. Now next moment, and that is the difficulty that this programming, actually program, something different is programming that is inherited in robot. Because programming, our things are not programmed, we do not know where is the program. We do not know where is our program. Our program is using the concept. But what we are writing in the paper and that is feeding in the computer, that is the program. That program should be such that it should not be too lengthy to take much processing time. So that before it takes its action, something may happen, this happens. So before that, the processing must have been complete. That is to gain that skill. So there are two types of sensor, active and passive sensor. And high medium is electromagnetic, radiation sensor, chemical sensor, and contact sensor, physical contact. Another one is external sensor, and one is proprioceptive, that is just internal sensor, deals with the internal matter. Like what will be the temperature of the battery inside the power source. If temperature rises, this then will minimize the use of the battery. That is the internal sensor. But what is there? The target point is this much. So that is external sensor. So camera is external sensor, and temperature sensor within the system is the internal sensor. Like INS gyroscope also internal sensor, because INS and gyroscope, that is inside that system, but what it is giving liver to fast, or you are just falling. That sensor will tell that you are just falling with a disbalance. So that INS and gyroscope will give that. So there are some mechanical sensors. So these are the concept. Again, some realistic sensors are there. Auto cells, mostly we know this auto cell, main sensor. Then some other general useful sensor, that is, but we can say that is chip, virtual chip. So that sensor is there. Very small, just like your GPS. That is not sensor. Very small sensor. So this is main sensor, and it's very much useful in your robot distribution seminar. The main products are also, it is high use. This main products for wheel robot, even your arm movement, even leg movement, you can use this in products. So sound, based on sound, there are some sensors like sonar, implement, PDL, this Doppler velocity log, PDL, that is also sound based sensor. So these are the sonar based sensors, sonar, forward looking sonar, and infrared also, that is also another sensor. This is proximity sensor because this type of sensor can sense in meter area. So this order sensor is chemical sensor, what is there inside this box. If there is something that is you can see sensor what it is, what information it is giving that chemical information. So that order sensor is also there. So this is the list of the sensors which are used in robotics. Actually in robots there are many sensors used. This is very compact gyroscope, very small one. Now you see another important part of this robot is the gripper. Gripper means what? Actually the utilization of the robot. How you utilize the robot for your target purpose. That will be fulfilled by gripper only. So as our hand, what it is doing is gripping something, not only gripping, writing, collecting your some objects, manipulating that object, whatever. Similarly, there will be one gripper in the robot so that it can act like an human hand, that is human these fingers. So there are some grippers. This is 2-finger gripper, 3-4-finger gripper. This is another one is the intelligent gripper. Intelligent gripper means while it is gripping, it senses that there is something I am holding. This one I hold. So I have the sense that as sensor is there, that's why it is intelligent. So some other gripper also, these are very simple, but this is anthropomorphic. So this one is the intelligent gripper. Now how we are gripping? How women are gripping? So for intelligent gripping, we have to follow this rule. First, you have the prior knowledge about the object to grip. Then, where to grip? That is target. Then identify the target among other objects. If there are many things, I want to connect that to one. That you have to identify. That should be there. Then move that gripper towards that object. Then reshape. Then before gripping, check the shape. Then contact between hand and object. Again, refine the grasping and reposition of the finger. So grasping is just refine. That means fine tuning is required to it. Because we are doing the same thing. Then successfully we are doing. So for robotic hand also, same thing should be same. So if that robot is intelligent enough, it may not not be mobile. It may be fixed desktop. It is manipulable. But that clipping method is to be an intelligent level. This includes as we can touching. Now end effect. Clipping is opaque. This is a clip. But effector is that is the end. Does not mean that maybe in effector and clipper may be same thing. There is no problem because for this is my end effect. And for after clipping this is the so in effector and clipper there is not much difference. But effector is this is the so you can see there are tools drilling, cutting, so writing your own on the topic. So that is the target point. So this target point will achieve by 100. So for a robotics, you can see this one is robotic arm. So this is robotic arm. But main effector is there. This is PUL. And this one is tape. So that what end is doing the same. And what it is giving the similarly, this is one machine. This is one clipping. This is clipper and this is end effector. So collecting this small coils. And here this is the gripper. And gripper and end effector is same. But while it is just pouring the water into it, that is the end effector. So bottle tip is the end effector. So target will be the calculation or not showing mathematics, but calculation will be according to the end point. That is the end point. So this end point should come. Otherwise, coding will not come. That is the end effect. So apart from this, for robotics, there are two things. One is path planning, another is motion planning. These things are also there. What is there? This is the process of moving the manipulator or moving the robot itself. If manipulator end is moved, that is that to which it will move. That is the path. You have to plan the path. And if that is the mobile robot, so you have to plan the path how it will go from one place to another. That is the target point. That is the reach. But for this you need that time variant variation, then pose of that object as well as the robot and the end effector. Then its velocity, acceleration and dynamics. All are correlated. You cannot avoid anything. So that is the both thing is motion planning as well as path planning. Now, what is the difference between these two? This is the path. You are moving this object. There is you are not thinking about motion. Whatever motion it is happening, let it. You are not planning. But automatically it is giving some motion. So this is the path you have planned. Now, if there is something, you have to plan the path, either pre-plan or offline or online or post-plan. While it is in action, then it will plan. But in a similar way, you can see there is also, you can see this one. It will stop here. That is the motion plan. So path is already there and then motion is also to be planned. Otherwise it will not fulfill your task. So there are while there is something mobile, you know, wheelbase has no problem. If there is 3 touch point, then it is stable. If there is 3 wheel, then it is stable. So there is no problem. But for human being, we are moving by 2 legs. For this horse, it is moving by 4 legs. But stability is an issue in it. So that's why you have to plan in which footprint or which footprint your system will be stable. That is the planning for gear. So this is another area of your robotic research. So each and every has some complexities as well as some easy ways. So human are moving like this. If you want to lift his right leg, like this you are lifting. So this is gait pattern. So what type of pattern we are following? Another part is your actuator. This is also very much important because we know motor we are using, but muscles, most of the animals, not all animals, they are using muscles. So that is from great your area where research is pending. So some research is going on for artificial muscle. So electroactive polymer also there. That is going on. But motors are already, we can see this is right. So this is the this is for second last. I will come another topic. So AI, which is the intelligence, artificial intelligence, this is mostly discussed topic in the order. So what is AI? It's very simple. What reaction? What action this human is doing is same action this will happen. That is this artificial intelligence. Intelligence is artificial because everything is dependent. Human, whatever human is giving the instruction, intelligence have to follow. So that's why it is artificial. But human what? Natural. That's why for human and animal, they are what? Natural. That's why their intelligence is naturally intelligent. So if that is there, we have 2 branches. One is creating AI system, another is uniting the AI system. AI system you can create, but how to unite? So I'm coming one by one. So this is, you can say this is AI based program, intelligent program. But it's not intelligent, it can only, this action it can do. It's only one action. But for any animal or any insect, you can say multi-action. So available is the vacuum cleaner. If there is some dirt, you can go there, you will clean. And then this robot engineer robot, the robot engineer, this robot itself is an engineer. So this is doing some engineering work, like assembling, opening the bolts or removing the pins, tightening the nuts, like that. And then this intelligent lever, it's a very huge size, only one is there in the world. That is in Dilip, that is in Japan. So just intelligence bring you this thing. So robot brain, as our brain is logical, so robot brain should be logical. So logical system and information storage unit of the robot is the brain. So there should be some logical information. part of the theory. So people have developed this method fuzzy logic. So according to that logic, critically the robot or system will decide what to do. That is one thing. So in this there are so many things. We will say raw data. Next is your genetical. So if some data are missed, what to do? You should not be puzzled. We are not puzzling, so robot should not puzzle. If data is lost or data is used, no, robot should not. That is to be solved through this genetical. So we have to fulfill the target by introducing proper code, that is genetic code, computer program. All are computer program, but following certain methods, algorithms, and some small mathematics. So this is one of the flow diagram of genetic code. So I am not going to this advantage and disadvantage. So it's the most intelligent one. It's an artificial intelligence. You can see chip. This is the brain chip. Our brain. Shape is like this. This is the in. Receptors. Everywhere on the screen you can find receptors. So this artificial intelligence is a neural network that is copied from the artificial network. So how it works? We will come to that. This neural network has this type of form. So there will be some input information which is called input layer. That is one gram you are just feeding. That is the layer. So inside what is going on? You do not know. We are listening to the sound. That is all. So inside there will be many programs and many things. You are feeding one gram. So inside air is there. So air can do something. What it is doing, you know. That is the deep neural network. That is deep neural network. So that is called medium. We do not know. So this is one another research area. And lastly, we are just listening the sound. So this is one block diagram for navigation. This is only one simple block diagram of the neural network. Now, any idea after reading these things and other things, other concepts, if you have any idea, you can generate your own neural network. So everything is welcome because it is in basic stage. So for basic science, you know that physics, chemistry, mathematics is the basic. Not only that, this is also basic science. So everything is welcome. That should be applicable because it is not only for basic but also it should be applicable for your robotics or intelligence. So this is the last one. All the things are there, but if there is no control, nothing will happen. So there are controls should be there. We know that there are two types of control. One is open loop control, because we do not know what after reaching what is the status, we do not know. That is open loop. But if we know the status and if we see that we did not get that exact one, then we can give some information to the exact location or do the exact place. That is the goal. Now only that portion covered. So that was the new one. And going some types of robots. Robots are basically two types. One is fixed, another one is mobile. Fixed robot, base is fixed here, so it is doing its action. And these are some of the types of fixed which are used in the industry. And now another one is mobile robot. These are some of the wheeled mobile robot. Okay. These are already present. These two-wheeled robot. This is mostly dynamically balanced, not statically balanced. And legged robot. Already there, these robots are already there. This is spider, robotic spider. So this is, we are calling this one is robot, but it is not robot, it is remote control. Remotely it is connected to the one. We are telling it autonomous because of no human intervention is there during this action. But here it is connected. Here it is wired. Some other robot also, step type, when underwater fish robot, and this is developed by Crash robot. So flying robot, flying back. You can see there is small mechanism, but it is remote control. Now we can come to this robot adapter. For any robot, this must be there. For any robot, this is the agent, maybe mobile agent, maybe fixed agent. So it will have to be sensor. So we have the capacity to get the information from the environmental physical perception, and according to the plan it can act. That is the in gross. This is general anatomy of the robot. Now any manipulator has this type of parts. So arm, indicator, actuator, sensor, controller, drive and software. And as well as this is the mechanical part. So as well as it has the motion. So this is the dynamics. This information must have to be there in the robotics. The same thing. So this is here you see number of links are limited and number of joints are limited. But in elephant fan, how many joints are, how many links are there? Basically, we do not know. That's why it is called redundant. So for this type of thing, you can see there are many joints and many links. Even in elephant fan, this is the there. So each and every robot has different anatomy. The anatomy differentiates, and according to that, their dynamics also changing. Dynamics of configuration, even dynamics, all are changing. So there are something parallel. Parallel in the sense you can see any of the links. They are not parallel, geometrically parallel, but action is parallel action. But while it is moving, all will move. Maybe one may not move, but other will move. If there is 6 connections, if one is moving, another 5 should have to, altogether 5 should have to be moved. So one may not move. That's why their motions are parallel. That's why it is called parallel robot. So there is anatomy is something different. So each and every robot has different anatomy. So mobile robot, according to their anatomy, we have mechanical structure, locomotor, actuator, sensor, control system, and power supply. So if you see this mobile robot, its anatomy is like it has structure that just then maybe if there is idea may be there, then drive system, that is the motor or your battery control electronics, and then sensors also there. So many things is there. So this is the practical robot, mobile robot. It has this type of components. So each robot has different components. Those are the animals. Our system has lungs, heart, all are related to one another. So for legged robot, this is the end cross, this is the this anatomy. This will have this head, arm, shoulder, hand, leg, trunk as well as foot. Then only it will be leg. So if it is a four-legged robot, then this will be, there will be many things. You can see the anatomy. So if you can divide it, if you can define the anatomy of the robot, it will be just 25% done. Then you go back. Because you have selected your components. Then only you can develop that. So this is bipedal. So there are kinematics also. And these are the components that is attached to this. Leg has defined anatomy. Each and every leg particular here that is used in robot, legged robot, that anatomy is different. So if you see that flying robot, that's already on video was shown. That anatomy is, you can see how many parts are there. So let us come to this automation and robotics. Automation and robotics. So, engineers use automation and robotics to meet our needs and wants. Why this following components? We can say making manufacturing more efficient, productive, and safe. Yeah. We will come later on to how that was developed, so stages of development. So, performing repetitive job, which and explore some places where human cannot go. So designing of assistive tools for people with disability. Then provide equipment in hospitals to help with surgery, delivery of food, or dispensing of medications. Somebody is disabled, not to take medicine. That also robotic hand or mobile robot can help. And also in household, this also household work. So before automation, what was there? People were making most of the things by hand. So it was costly and accessible to a few persons, those who are rich. Now, after automation, we are not going to robotics. After automation, in the first stage, what is there? While this is electricity was developed, we have discovered, then the automation introduced. So what is that? These changes is made possible for one worker to produce 10 times the quantity of product in the same amount of time. That means the production time reduced as well as production cost reduced. So it is product is accessible to few people. So more people. Before it was few people, now it is more people. In the first stage, because price is lower in this, And in second stage, while the program was developed, so automation has some addition, so that human intervention for critical job or repetitive job is reduced. And that repetitive work means what it is doing? It is finishing or the product quality is good. Because human cannot draw just like A, same A already. So but machine can do. Okay. So that is nature of the second step. So that cost again reduced. So more people just can access the product. Now the third stage, while completely automated. So price reduced, product quality raised, and people can access, can purchase that commodity very easily with no cost. That possible only for development or creation of powerful systems, and that has been after 1980s. So these are the some automation. This is your garbage control, warehouse, and this is production oiling, and now home management system. This is so everywhere automation is used. So automation just there is if you add the robot, then the automation now it is additive towards flexible manufacturing system. So while this technology which deals with design, construction and operation of robots in automation, then it is becoming robotics. So robotics is a part of automation in manufacturing or in industry, in the industrial aspect. So we know that the robot is a machine that performs complicated tasks and is guided by control or by program. Control, remote control, with human control. So this is in space. This is education, and this is medical, and this is manufacturing. So everywhere robot is space, education, medical, and manufacturing. So what is the difference between automation and robotics? Automation is replacing human input with electronic control. So minimum human intervention is needed in automation. And robotics involves the design, construction and operation of robots. And a robot is a machine that performs complex tasks and is guided by control or the program. So this is very much clear. So industrial robot. So this is there are some things in industry how robots are used. So before 18th century, all production was before this century, all production was human based. Now, as machine was developed after this 1784, this is all room. That was the automation. First of 1784. That was this information is from Europe. Not from India. India was actually they are developed this. This German trade interest is they have mentioned this. It is from European Industrial Revolution. So after that, in the beginning of 20th century, then second industrial revolution cyber physical system CPS has introduced in January 2011. This is future project by German Federation, and that is controlled by German government. So it is called Industry 4. The Industry 4, we know Industry 4, Industry 4, what is Industry 4? This is Industry 4. Industry 4 is completely wireless. Your system will be here. You can send the instruction to GPS or to internet. Then IoT of things. Now you can see IoT of things. IoT will take the action. Whatever you need to do. So industrial robots is general purpose reprogrammable machine that processes certain anthropomorphic characteristics. That is the industrial robot. Anthropomorphic, that is human. So it will work in hazardous environment, repetitive work cycle, it has repetitive work cycle, then have the consistency and accuracy of the production. Difficult handling task of human with this complicated shape. Human cannot do that just like you can do. How human can read that shape? So that robot can do it. Multi-shifting operation. Human cannot work continuously. 4 hours, 2 hours, 3 hours, then you will be in a problem. So he has to take this machine cannot. It will continuously do. As this robot is reprogrammable, so that performance is flexible. And you don't interface with the computer system. That's why it is PLC model. So, robot used in industry worldwide is like this. Where is India? Can you see? Anywhere in India? No. So we have enough scope. And this result is 2021. So types of industrial robots. Industrial robots are Cartesian type. All are translation of motion. Then cylindrical. So one is translation, two motion is translation, one is rotation. So that is cylindrical. Then spherical means three motions. There are two rotation and one translation. That is spherical. Videos are not available. That's why there is scala is there. Scala root. Two rotation, one translation. With all our industrial robot, and this is the most used and modern robot, that is more articulated. This in manufacturing, highly accurate manufacturing, this parallel robots are used. Though it was developed for flight simulator, now it is used in industry for precision manufacturing process. So this is some of the action. This is welding. This is lifting the head, and this is application of the robot in the industry. See in automation. Automation does not mean that not only this automotive everywhere. Next is this is assembly. It's very easily we are assembling. So robot performance repeatedly it can do. Then painting of car, not only car, very complicated things, also very your radioactive material, toxic material, that also you can paint. chemical that is dangerous for human, that analysis chemical for chemical experimentation, that also can be performed by. And you can see all are articulated, mostly are articulated. Now robot for scientific exploration. So this in the International Space Station, Canada has developed one robotic arm that was installed in the space station. This is only the scientific exploration, no other purpose. Because it cannot manufacture, it cannot do something else except for exploration or manipulation of some space. So this is space robot and human cannot do. So this is Mars rover. Now, if you just escape, this is underwater. So underwater human cannot do for inspection. So this is also exploration and that is inspection. This is underwater robot. Underwater remotely operated vehicle because it is stable. This is what signal means power as well as your communication. Communication cable as well as power cable is there. That's why it is what it is. This anatomy already we have seen. This is another ROV, remotely operated underwater vehicle. This has many complicated parts. So that ROV is manipulated. That underwater remote is manipulated. That is also. This is also another one. This is ROV, remotely operated vehicle, and with manipulated. This is for underwater inspection. Underwater structure inspection, inspection. This is for AUD. AUD has many components. You see propeller and that. So these many things are there. Propeller, tail, magnetic system, control system, mechanical. This is for moving. Then power module and camera. Very simple thing. But what we have done, that is also there. This is another AUD. This was done by CBN. So this underwater exploration and space exploration, very big institutes and organization has taken this part, but no private company. Because it is huge investment. Once the object is lost, it is done. Underwater and space, even in air. That's why government is taking that risk to explore those things. After development, it may be utilized. But some other purpose is there for military applications, etc. Those things underwater is there and underwater robots must be there. And in space also, we have to reach. Otherwise, by this term there. Because of space security. Security is very important thing. So this CBN develops such type of case also. So exploration, this is underwater exploration. Why underwater exploration is required? Because of that seismic activity under the sea and the terrain of under the sea. What is there? Polymetallic nodules. What nutrients are present underwater. This. Otherwise, human cannot go. This is beyond the reach of the human. And as it is under the water, so sensors are necessary. Either light-based or acoustic-based. These two type of sensors that is working under the water. In space, all the sensors are working except sound based. But in underwater, sound based and light based. Many types, many sensors. That depends on sensors, whatever you develop, that depends on the application. First you have to identify what is its application. Not necessary. So you may be one team. There's one team, they are team, electrical, therefore is that each person has to develop their own sensor. Maybe mechanical is there. If it is for underwater, mechanical and in space there is no problem. Mechanical also in underwater is very not only that underwater for the real good zone or highly pressurized zone, even poisonous zone. That also very important. So this is the ROB in action. You can see this is another ROB because it is cable. Data is connected. So ROB is manipulated. So that one has ROB is manipulated. So this is AUV. There is no cable connection. So this is autonomous underwater vehicle. Because if this is lost, means lost. Power off means nothing will be left. So before exhausting power, you will have to turn to the starting station or you go up to the surface. So this is ideal vehicle for inspection purposes.
Underwater, like what are the routing decisions, like how it will come back to the ocean, the direction is given to that the power is.
Power.
Uh,
See, that depends upon your mission time. First, if you have one, just consider one autonomous system. Autonomous system means everything is inbuilt, including power system. So as it is under the water, so power is fixed. So 1 kilowatt power, if it is stored in the battery, that will be, so before exhausting that 1 kilowatt, that means almost 80% power is, if it is exhausting, it will have to come either on surface or come to the
automatically it is.
automatically.
It will
It will give signal, intermittent signal, or it is self program. So it will, whenever it will reach to this level, it will go back to this original position.
Battery level is up.
That will be compared. Also that logic is set within that. Within the
But routing
program.
protocols are like while taking the decision whether it may obstacle, it may get
That sensors are there, obstacle avoidance capability must be there. As it is autonomous means everything will be inbuilt. It will be intelligent.
like in the lab we know only about the radio frequency that is utilized for taking in the wireless
Radio frequency will work on the surface only.
surface only, but it is underwater.
Underwater is sonar, sound based.
Sound based.
Either sound based or for few meter distance it is light based, camera based. Nothing else, nothing will work.
Nothing.
Only these two sensors will work underwater. And in space, except sound, everything will work. And in surface, everything, all will work. Okay,
One is
that
you said it is a which one the two? One is
underwater, sound based and light based. So this is one experiment. How manipulator will bring this ball. Very intelligent manipulator. So there are some sensors in the finger. So it is trained. It is training to the manipulator so that it can click that of that second. see that ball only gets it. That is the training. If it is shape is small enough, you cannot do. If it is large enough, not do also. That's why you have to install the intelligence in it. Instead, intelligence in the sense of your either through some programming, visual programming, or that is integrated with the camera, or some sound system or infrared, any sensor. Then only it will be, so that encoder you have to identify. So just here it will have to understand that. First we given that training, so it should have understand this here. Our pose will be like this, finger pose will be like this. So it is more, it will expand, it is less, it will contract. Like that intelligence, if it is introduced into the system, then only it can work. So, though it has no use at present, this emotion. So that is also AI, intelligence. So this emotion also mechanized. You can say this action is always mechanical. So that emotion is mechanized in India. In India, nobody is doing this. This expression astonishing, stating something, stating. So this is space manipulator. It's manipulating this space of the space station. So robot also used in agriculture, precision agriculture. Not for any, not precision agriculture, even lab based. You can say it is lab based. But in practically, somewhere some plucking of flowers and picking of some fruits, that robot is also there. Very basic because of its disability. So you can see this complicated complication of use of robotics. See, this is one remote control robot that was sent into the site of the Fukushima Daiichi nuclear power plant in Japan 2011 while the plant was destroyed. What happened? As soon as it entered into this water, heavy water zone, due to this radioactivity, its all the wirings melted. So the robot lost. That's why there is no stability. That while your robot is reaching inaccessible area where human cannot go or cannot retrieve, it will get the system redundant. That's why it is called, this robotic research is called basic system, because it can cost. And dependency for underwater, this already real industry robot is there. Medical, surgery robot is helping. So this is your medication. See that by sensing its pulses from the arm, this person is actuating this finger. This robotic, so it is robotic hand. So this robotic hand helps for medication to helping to take the medicine. So this is also military application. Robot is also used in military application. So this is track based. Now for entertainment, you can see there are many robots. This humanoid robot, that is also national humanoid robot, that is also for entertainment, not for use application, industrial application. That is for scientific exploration. So these are the modern robots that is available in now in India. Now we have to remember this was Thomas Edison. To invent, you need a huge imagination. Huge imagination means which can be transformed into reality. Imagination means anything. If it is not transformed into reality, that has no value. So that's why it is good imagination. But and a pile of junk. That means you are in puzzle. What to do, what not. Then how to solve it is the discussion of everything. That's why Thomas Edison wrote that to invent, you need a good imagination and a pile of junk. So many things in it, which you can see it may not be useful at present, but may be useful in the future. So this is actual activities of CMI. I am in underwater robotics team. So this robot is called remotely operated underwater vehicle (ROV) that was developed for operation at a depth of 500 meters. It is stable. So all the power and control was done from ship, that is from station. The human is controlling by giving the camera picture in the video. And later on, this one was just developed in another system, ROV system. That is this one. This is also ROV control. Those are underwater. Then we entered into autonomous system. Even parallelly ROV is what is going on. We entered into autonomous underwater. That is this. This was developed in the first time. That was developed for 150 meters. Later on, that was developed for 500 meters. So 500. This is 150. So this two will be practically together. So it is decided that is their physically that one that we are on that was the first ground. That is this. Now presently this Navy has the problem that once it is launched, the power, the exhaust power will easily, within 1 and 2 hours the power will exhaust. So again it will have to retrieve, recharge, then deploy. We avoid that thing, we are just developing one system so that the AEV can be recharged, the battery can be recharged under the water. That is underwater docking and moving and docking system. So both AEV as well as this docking system with the so this is the currently going. Currently this is the process. Apart from that, this Dilip was concept was also designed but not practically not manufactured. This was designed and data are all, everything is there. Software is also there, but it was not manufactured. So this is military. There are 7 segments in it. 1, 2, 3, 4, 5, 6, 7 segments. And each segment has 4 legs. Each leg has minimum 3. So 3 joints. So 3 into 4, 12, 84. Degrees of freedom is there. That is controllable. In robot there are two things. One is degrees of freedom which are controllable, which are not required to control. For redundant robot, redundant joint, you may not need to control the joint action. Suppose your spring is there, tentacle is there. So spring is pull. What will happen? Whatever the joints are there, that will automatically it will act. Only you have to just pull it. That's why those are called redundant. But here the redundancy is not there. All are controllable. That's why it is the system has 54 degrees of freedom. But each your junction there is no actuation. That means each junction there are 6 junctions. So these 6 joints are not controlled. 6 horizontal, 6 vertical. That means 6 into 12. 12 joints are not controlled. That's why 12 uncontrolled joints are controlled. So similarly, this is also planned and designed. So this is the latest proposal. Actually, it was not from India. So there was one parallel robot which will be useful for mining navigation. Anyway, these are the activities that is going on in underwater robotics and autonomous systems. That is where I am a part of that. So the best robot is this person, this man is using, this scientist is using the best robot, which is the AI-based information it is collecting, and that is writing in the screen. He is not writing anything. That information is imprinting in the screen automatically. So this is the, we can say this is the best application of AI, artificial intelligence. And what is view about artificial intelligence? What is his view about it? See, in 2017 November, in an impressive show that I fear that AI may replace humans altogether. If people design computer viruses, someone will design AI that inputs and replicates itself. This will be a new form of life that outperforms. That is his view about AI. He is utilizing AI, but that is his view. So acknowledgement and thank you for giving me this opportunity. You cannot say it is applied research. You cannot say it is basic research. So government is funding in this, and in interest of government is now it is AI based and IoT based.
Yes, that's for transformation.
That is transformation. And policy is that you have to utilize minimum money, give the maximum output. That is the fact. That is the fact. And initial investment of developing such type of your system is huge. Actually, no concern, private concern is interested, basically in India, interested to invest money for R&D work. That is one backlog for us. You can see Honda is private. They have developed too many products there, that is from 30 years. They are researching on that. Now the stage is almost human. They are performing certain tasks as like as human. But they invested for 30 years, but behind they will get nothing.